Well, good afternoon, good morning, or good evening, depending upon where you are in this world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for the event, and I welcome you. We have a really interesting webinar on tap today, but before we get started with it, I do have a few housekeeping items to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you'll be able to access it on demand. We'll be sending out a link post-webinar that will take you right to the event on demand. We also are taking questions from the audience, so if you have a question for our panelists today at any time during the event, please just use your GoToWebinar control panel and submit your question, and we should take probably around 10 or 15 minutes near the end of the presentation and go through those audience questions. And also please pay attention because we do have 3 polling questions during the event. We would really love for you to participate in those. Okay, with that, we'll go ahead and kick off today's webinar, which is building a Kubernetes app with Amazon EKS. Our speaker today is Laura Frank-Taco, who is Director of Engineering at CloudBees. Welcome, Laura. Thanks for joining me today.
Hi, everybody. Thanks, Charlene, for the wonderful introduction.
Oh, no problem. Before you get started, though, I mentioned poll questions, so I want to send out the first poll question just to kind of gauge the audience here. The first poll question is, do you use containers for development? Simple, yes or no. We'll give you guys a few seconds to submit your answers, and then we'll go ahead and close out the poll. But while we're waiting, as I said before, if you have a question at any time during the presentation, just go ahead and submit it using the GoToWebinar control panel, and we'll get to those questions during the Q&A period. Okay, I'm going to go ahead and close out today's poll and the first poll and push out the results. I think you guys will be really interested in seeing the results. The majority of people are using containers for development, Laura, so I'm sure that that's a very good thing for your presentation today.
Yeah, definitely. So the main focus of the presentation is going to be Amazon's Kubernetes offering, also known as EKS, but I am going to talk about how to develop on a containerized application locally. So if you're using containers for development, there's going to be a lot of stuff in the webinar that's probably kind of old hat for you, and then hopefully you can still learn a couple new things. Cool, I'm going to jump right in. So Charlene already gave me a wonderful introduction. I'm Laura Frank-Taco. I work at CloudBees. CloudBees is a DevOps company. We have a couple CI/CD offerings. And today I'm going to spend the next 45 minutes roughly talking about how you can build a Kubernetes app with Amazon's EKS and automate deployment to that cluster using a tool called CodeShip. We're going to go over quite a bit of ground during this webinar today. So we'll talk about what EKS is, how it's different from other Kubernetes offerings. We'll talk about how to even get an EKS cluster up and running, what you need to know, what you need to do. We will automate an app deployment to EKS with CodeShip, which is a CI/CD tool that's offered as a SaaS, so subscription software CI/CD. And then finally, we'll round out with a couple CI/CD best practices specifically for deploying your containerized applications to production with a CI/CD tool. Throughout this webinar, we are going to focus a lot on EKS, which again is Amazon's or AWS's, Amazon Web Services managed Kubernetes offering. It hit GA in early June of this year, so it's still pretty new. And in fact, managed offerings from infrastructure providers like AWS and Azure are pretty new. Google has had one for a little bit longer. Kubernetes coming out of Google is kind of the reason that Google has a little bit of a head start, but Amazon and Azure have caught up, certainly. I'm also going to talk a lot about CloudBees CodeShip, which is a customizable CI/CD tool that is offered as a subscription SaaS product. It has been designed with containerized applications in mind. So if you are using containers, you're packaging your applications in container images, distributing them to a registry, maybe pushing to a cluster using Kubernetes or Docker Swarm, CodeShip is a great fit. If you're not using containers, it's pretty flexible. So we kind of have a workflow for wherever you are in your cloud native journey or whatever requirements your application has. So I'm going to show off a couple of features of CodeShip and sort of use that as the backbone to our application deployment story. Kubernetes has definitely a lot of mind share. If you are paying, I think, any attention at all to the cloud native kind of developer trends, you've probably heard a lot about Kubernetes. It's really popular because it offers you it gives you the ability to express your application and application's requirements in kind of a config as code format that's portable, and you can run it in that declarative format across a lot of different environments. So if you are getting started developing locally, you can use tools like Minikube, you can use Docker for Mac or Windows. Both Docker for Mac and Windows come with a built-in Kubernetes environment, so that's pretty easy to get started with, especially since you're probably using Docker if you're using Kubernetes. If you're not interested in installing anything, there's also an in-browser option, which is playwithkubernetes.com. It's similar to playwithdocker.com. You just go to a web page and you get a little terminal in the browser. So nothing to download. It's pretty easy to set up. It's kind of a nice way to kick the tires a bit if you're not too familiar with Kubernetes. Getting into the managed and kind of running in production, what options you have for running a Kubernetes cluster. EKS, AKS, GKE, there's a lot of three-letter acronyms for these managed Kubernetes platforms that are offered by infrastructure providers. So these are really great solutions if you are, for example, running your entire workload on AWS already. It makes a lot of sense to use EKS because you're going to be able to kind of double dip and use a lot of the same patterns and the same constructs to run your Kubernetes cluster as you're using to run whatever workloads you might have in EC2 or whatever compute needs you have. The same goes for Google and for Azure with their managed Kubernetes platforms. I think the one downside to these is that it is sort of all into that infrastructure provider. So if you're not really comfortable with sort of playing like putting all of your chips on one cloud infrastructure provider, you might be more interested in these cloud agnostic third-party managed Kubernetes platforms. So Rancher, OpenShift, CoreOS Tectonic, Docker Enterprise Edition, those are examples of sort of third-party, and I say cloud agnostic because it's more of a bring your own cloud. So for example, Docker Enterprise Edition you can use with Azure, you can use with AWS, you can use with Google. It's pretty flexible. The only thing to look out for with third-party providers, because they're springing up everywhere, is that they have that little certified Kubernetes kind of like a shield or badge on their product. So just to make sure you're getting true upstream community-backed Kubernetes and not some fork or some proprietary thing that might actually lock you in. So with your application defined in the Kubernetes deployment, you're able to run your application on a multitude of different platforms. So whether it's locally a managed Kubernetes platform offered by one of your cloud providers or on a cloud agnostic Kubernetes platform, with that declaration, you can kind of just take your app and it's pretty portable, which is one of the big advantages of Kubernetes, aside from the other highly available containerized application stuff. I chose to focus for this webinar on two things. So one is orchestration application, and the other one is CI/CD. And I'm not just kind of arbitrarily putting these two things together. If you're familiar with the CNCF, which is the Cloud Native Computing Foundation, they have this thing called the Cloud Native Trail Map. So if you're one of the people that said, no, I'm not using containers in development yet, or you're very early on kind of orienting yourself in this very vast and sometimes very confusing container world, this is a really good way to help you find your way. So the first thing is containerization. That's the prerequisite. And I'm not going to touch on that today. So if you don't yet really understand Docker, if you haven't maybe written your Docker files yet or gotten your application code into container images, there might be quite a few things in this webinar that are in your head, but I'd encourage you just to kind of power through and then go back and reacquaint yourself with the content once you've had a little bit more time to practice with Docker and containers. Once you have containerization down, though, the next step that's suggested by the CNCF and also suggested by me is that you get CI/CD running. So during his keynote at KubeCon in Copenhagen this last fall, Kelsey Hightower said that if you have your application in containers and you don't have a way to automate the deployment and recover from failure or just simply deploy whenever you merge to master, like you are not ready for a solution like Kubernetes. It's really going to make things a little bit more complicated for you. So the first thing to do is to get up your CI/CD so that whenever you do make a change to your source code, it's automatically built into a new container image. That container image is then pushed to a registry, and then you're able to, for example, to deploy it to an EKS cluster or any kind of other cluster. So we'll focus on both of those two things, CI/CD and orchestration. I want to make sure that we all understand that CI/CD is definitely a very important part of this, and it's really great to have the backing of the CNCF to emphasize its importance as well. Getting in a bit more into EKS, did quite a lot of research in preparation for this webinar and how I can present everything in a way that's most useful to you. And I think the little phrase I came away with is that EKS or any other Kubernetes platform that's offered, especially by an infrastructure provider, the key thing to remember is that it is managed, it is not magic. So there are still lots of things you're going to have to do by yourself, and learning things the hard way is still going to put you kind of at a competitive advantage instead of kind of relying on solutions that maybe obscure some of the hard bits from you. I love learning things the hard way so that when things break, I have a bit of an easier time debugging them. To be successful with EKS, you will need to know certain things about AWS and the way that it works. For example, IAM, users and roles. You'll be able to, you need to be able to use CloudFormation or at least understand how to follow the docs and kind of use stacks and set things up. You also need to know a little bit about EC2 because you need to give some input regarding what your compute needs are for your cluster. Those things are really hard to do if you've never used AWS before, so I'd encourage you to kind of do that background work before getting started with EKS, otherwise EKS is going to be a little bit challenging for you. You don't need to know how to do everything from the CLI. Using the GUI is totally fine. The CLI is helpful, however, so I'll show both the GUI and the CLI. What EKS will not do for you is magically teach you Kubernetes. So you definitely need to know how things are working. You need to know how to write your configuration files, and you need a basic understanding of kube control or kubectl, depending. I don't want to start a war on how it's pronounced. Depending on how you're going to access it, you need to be able to access it locally and then use a configuration file to access your EKS cluster from kube control from your laptop in order to be very successful with EKS. There is a really helpful QuickStart guide from EKS. It will walk you through all the prerequisites, kind of hold your hand, give you templates, and help you get your cluster up and running. It is, I think, a little bit easy to get stuck in certain places. So I'm gonna just walk you through an even quicker QuickStart guide just to make sure that if you're gonna rewatch this webinar and kind of follow along and try to set up your own cluster, that you have a little bit of guidance. So the first thing that you need to do is to create a service role in the IAM console. This is just something to let, to give access to your EKS cluster. You need a VPC so that you can run your traffic. So EKS is only available in US West 2 and US East 1 as of now. So if you need to operate in regions other than those, you might have to wait a bit. Otherwise, you'll be ready to go in US West 2 or US East 1. I'm going to run everything in US East 1. I am in Austria, so US West 2 is just a little bit too far away. Once you have all of those prerequisites installed, you can install the kube control command line utility, and then also this little thing called AWS IAM Authenticator. That's going to help authenticate against your Kubernetes cluster using your IAM credentials. After that, you're finally ready to actually set up your cluster. So there's quite a bit of prerequisite work that you need to do in order to get to that phase. Once you have that cluster set up, I think actually saying set up the cluster is a little bit of a misnomer because it's really sort of saying set up your management plane. You can configure access to that management plane and be able to access it locally, but the worker nodes are not set up for you when you press that give me an EKS cluster. You have to launch them via CloudFormation. I missed that the first time I set up the cluster, and it probably took me about a half an hour before puzzlingly trying to go through the docs again and realize like, oh yeah, dirt, I did not actually give any worker nodes to this cluster. So I think that's an important thing you can learn from my mistake and hopefully save yourself a bit of time. If all of this sounds really painful and you just have no desire to click some buttons in the console and you'd rather do it all from a configuration file, that is a great approach. You can set up your cluster using tools like Terraform, and there is a really, really good guide to getting up and running with EKS available on the Terraform docs. And it's so great, I don't even need to go through it or give it any other explanation. So find the link or Google for it, and you can go through kind of a step-by-step guide to get your cluster up and running with Terraform. Cool. With that, I want to just take a little bit of a test drive through the GUI to see, to show you what you're going to see as you're setting this up. So under services, you'll find EKS, or you can search for it because there are a lot of services. And really, this is it. You're going to see the names of the clusters that you have set up, and then you'll see an option to create a new cluster. Underneath this just gives you some metadata about it, like authentication stuff, endpoint. So I'm not going to show that during the demo. If you're more of a command line person, you can certainly see the same information from the command line. So just using AWS EKS list clusters, you can see everything. So that's sort of the AWS EKS side of things. But as I said before, during that QuickStart guide, one of the most important things that you have to do is to configure your local kube control to be able to access that cluster remotely. And the way that you know that you've done it correctly is if you can issue this command, get nodes, and see the nodes from AWS come back. So I've gone through, it takes probably about 10 or 15 minutes to set up a cluster. So I didn't want to do it during this webinar just because time is a little bit limited. But I did it beforehand, actually quite a while beforehand. 8 days ago, I set up a cluster. But you can see that my worker nodes are there. I'm able to see everything. And I actually set up an application that we're going to use throughout this webinar. And this is a sample application. We're going to make changes to this locally and then kind of see the changes go all the way through our CI/CD system and then eventually deploy it to our EKS cluster. Cool. The application that we're going to use is a really simple voting application. If you have ever attended a DockerCon, this probably looks very familiar to you. This is the sample voting app that's become like the canonical example to use during keynotes and other things. It's a little bit of an interesting application because it was sort of designed just to show the power of microservice architecture and to show the power of tools like Kubernetes or Docker Swarm. So the main services that we're concerned with are the voting service, which gives you this cats versus dogs, and you can choose one. Obviously, dogs are better, so I chose dogs. Don't hate me, had a cat when I was a child, but there's also results, so you can see how many votes came in and who voted cats or dogs. There are 3 other services that are not as interesting to us. There's Redis. There's a worker service that's actually written in .NET. I have never touched a .NET application, and the great thing is I really didn't have to know anything about it in order to run it because it's in a container. And then we have a database, which is a Postgres database. If you are interested in voting, Kathy dropped a link. So this application is up and running on EKS. If you have a strong opinion about cats versus dogs or want to prove me wrong that cats are better, please, I encourage you to vote. It will just help us illustrate the point of our persistent volume claim when we talk about database data a little bit later. So the service architecture, again, this is a little bit overly complicated just to sort of prove the point of the power of Kubernetes and the microservices. So we have that voting toggle, cats versus dogs, that pushes the vote into Redis, which is picked up by the worker, which is written in .NET. That worker then dumps it into the database, which is Postgres, and then the result service reads from the database to show us the results. It's a Node.js app. So it's kind of a long round trip for a vote. The really interesting thing about this architecture and the reason that I chose to use this application is that we have 2 different types of services in this. We have services that are just dependencies, and we can use those from Docker Hub. So Redis and the Postgres database, we can just grab the container images from Docker Hub, or it could be any registry, and just run them. We don't actually have to write source code for them. But for the other 3 services, we do have to write source code for them, which means that we also have to test it. we have to create the images for it. We have to push the images to some registry so that our cluster can pull them down. We're going to use CodeShip to automate that test create pushing, and then use CodeShip as well to deploy them to our EKS cluster. So the first thing that we're going to do is try to get this running locally. And one of the things I wanted to talk about before going into a demo is how to switch back and forth between local dev, so where you're developing your application locally, and then being able to access EKS from the command line, like I showed previously in the demo. And in Kubernetes, there are these things called contexts, which basically say, this is the situation you're in right now, this is the context that you're in. So if you do the command kubectl config get context, you'll see all of the contexts that you have access to. If you're using EKS and you have it configured correctly, you will see the context with the name AWS, the cluster name Kubernetes, and auth info AWS. So that is expected, and that's how you know that you have set it up correctly if you are setting up an EKS cluster and configuring it to run locally, or configuring it to access it locally. One way that you can add another context, so let's say that you have Docker for Mac or some other cluster that you're running locally, and you want to make sure that kubectl can access that cluster, is simply to add the config file to this environment variable that's called kubeconfig. So if you haven't dug into this, it's, I think, maybe one of the lesser publicized features of kubectl. There is an environment variable that basically just stores the path to your config. So you can just append to it, similar to how you would append to path, to give or to put like 2 config files on that path. After you do that, you can say get context, and you'll see multiple contexts and you can switch between them. So that's one way to do it. I am a very nervous person and also like very error prone. And I think if you've accidentally ever like done something against a production database or whatever, you found that it's just easier to keep things very, very separate. So that's what I prefer to do. Instead of appending multiple config files to my kubeconfig, I just like straight up overwrite it. That way I only have one context and I know exactly where I am, exactly what I'm doing, and I have no risk of like accidentally performing some action against a cluster that I wasn't aware that I was interacting against. So I'm in a demo just switching the contexts. Cool. So I have my current context is AWS, and I'm up against my, or accessing my EKS cluster. I am going to just pass in a different config file. So I like to use Docker for Mac when I'm developing locally. If I want to run a local Kubernetes cluster, I think Minikube is great, and I did use Minikube for a long time, but I just found it easier because I'm using Docker for other stuff anyway. It's already running. If you don't know about Kubernetes available on Docker, it is in your preferences. You can just say enable Kubernetes, and then you'll see this nice little green dot that says Docker's running, Kubernetes is running as well. Now, when I say get nodes, I don't see my my EKS cluster. I just see my Docker desktop cluster. So that is great. I can deploy to it just to make sure that, actually before I do that, I have a bunch of stuff in here. This is where all the source code is for my example voting app. I have a special development sort of version of my kube deployment. It's been a little bit modified, and I'm going to use that just to verify that like nothing is totally broken before I make a change and commit it up to GitHub. So I'm going to do that just with the good old handy dandy kubectl apply, and I'll see all of my services, all of my applications be created. It takes a little bit for that database volume to come up, so we can just take a poke in here, but we'll see all of the results, deployments, and we'll see the corresponding service to make it possible for us to access it. We'll see a persistent volume claim for Postgres. We'll see the Postgres service itself, etc. We'll just take a little peek at what's going on over here. So this is just the local version of what I have running on the cluster right now. So I have cats and dogs, and I can vote for cats. I can change my vote. I can go back and see that it's cool. Dogs have it 100%. So this is great. I have it set up locally. The only problem is that Kubernetes isn't super ideal, or at least it's not my personal preference to use Kubernetes for development. I like to do something like this where I set up my application on a local cluster just to make sure nothing's totally broken, but I actually prefer to use Docker Compose when I'm developing. I'm more comfortable with the workflow because I started using Docker long before I started using Kubernetes. So I'm just going to kind of blow away everything that we set up, which is fine because it's just in a config file. So if I need it again, I can set it up. And then I'm going to start it with Docker Compose. I'm going to pass in the -d flag, which will have it run kind of in detached mode so that I don't get log output. And then I can go back to my browser and I should see pretty much the exact same thing running. And I'll just verify that it's up and I can vote, change my vote, and everything is all good. So let's talk about, you have a Jira ticket and cats and dogs is like overplayed and really over. So let's change it to something where people have a little bit more, maybe stronger opinions. So I am going to change, instead of cats and dogs, we'll make it a debate about tabs versus spaces. So I'm just going to go in here and change it to tabs versus spaces. Because the vote and result application are, they're different, I'm going to also have to change it over here in the result. There's some really good non-semantic CSS in here. Don't judge. Spaces. Cool. So that source code is being mounted into my container as a volume. So even though I didn't rebuild any image, I can go over here and refresh and see that my tabs versus spaces thing is done. So that's great, but our production version obviously is still cats versus dogs, and we need to figure out a way to get the local changes that we just made onto our EKS cluster. And to do that, we're going to need to do quite a few things. So as I mentioned before, EKS is managed, but it's not magic. And CI/CD and deploying to the cluster is also not magic. So we need to make the change locally. We've done that. We can run tests locally. Then we need to push to GitHub and trigger a build on CodeShip. CodeShip is going to build the images, run tests against the new code, push that image to a registry, because that is our distribution mechanism for this source code. If that's all green, we have a green build, then we're fine to merge to master. Once we merge to master, and only when we merge to master, do we actually want to trigger a deployment. So I don't want a deployment going out to my cluster on a feature branch. That is very dangerous. So I want to make sure to restrict those deployment events only to master branch. And then finally, after that's all finished, I can see our changes in production. The really cool thing about CodeShip, or really any CI/CD service, is that you can automate a lot of the stuff. With CodeShip, it's really simple because CodeShip was designed for this workflow in mind. So we have a lot of extra kind of like sugar in our syntax to help you accomplish these things. However, it's not just about running the tests or building the image or pushing the image. It's that deployment step that's really the trickiest part. And I think that's just a general tricky part of CI/CD, whether you're using EKS or your own Kubernetes or whatever you're trying to deploy to, is that you have this build machine that's maybe not in your control. And you need to give it what it needs to be able to connect securely to your production environment. That's a little bit scary. So I'm going to talk you through how you can do it with CodeShip and some of the best practices and sort of security-minded features that we have to make it a little bit easier. So if you
Hey,
remember,
Laura, sorry, don't mean to break in, but we do have a polling question. I'd like to run past the audience real quick if you want to take a breath here, and we can go
oh
ahead and
yeah,
push it out. Yeah.
that's a
So
great
this is
idea.
okay. Give yourself a little break here. But the polling question is, have you used CodeShip before? And again, super simple, yes or no. So we give you guys a couple seconds to submit your answer. Then we'll take a look at the poll results. Also, while we're waiting, just want to remind the audience, if you have a question for Laura, go ahead and use the control panel, submit your questions. And we'll get to those after her presentation. Okay, I'm going to go ahead and close out the poll, and we'll take a look at the polling results. Right now, it looks like the majority of folks have not used CodeShip, so there you have it. And
Cool.
I'll let you get back to it now. I'm going to hide these results.
That's great. Well, I'm happy to be the one to give you maybe your first taste of CodeShip and show you how you can use it to easily deploy to your EKS cluster. So if we think back to previously getting the authentication set up locally, I mentioned that the EKS cluster uses IAM credentials in order to authenticate to the cluster. So all of the authentication that we have set up locally, authentication against AWS and those credentials, we need to provide to the build machine so that the build machine can access the cluster as well. So whether or not that's or maybe a service user or robot user that has different very limited credentials, or however you manage that with your team, you just have to make sure to have those credentials on hand. We will rely on that kubeconfig and that's sort of like that get context, the AWS context, and all of the extra stuff around that configuration. So having your kube control set up and installed, configured locally to access your EKS cluster will help you kind of replicate that process to get CodeShip to be able to talk to your EKS cluster from inside a build. We're also going to encrypt everything using an AES 256 key that is the default project encryption key from CodeShip. In order to do that, CodeShip has a CLI to help you encrypt and decrypt files. It's called JET. There's a link to download it. It also can, it's literally the exact same build runner that will run your CodeShip build, just with a CLI entry point. So you're able to run whatever would run on a build on CodeShip on your local environment before you commit. So if you just want to test stuff out or you're trying to set up a project, it can come in super handy. So, and then on the CodeShip side, we need to make sure to have that AWS IAM authenticator available to the build. CodeShip has a couple of our own images to help you do that. If you have kicked the tires with EKS before and you're a little puzzled about this AWS IAM authenticator, it used to be called the Heptio Authenticator AWS. It came out one of the SIGs in Kubernetes. It just has a name change. As far as I remember, when I checked today, even if you say AWS IAM Authenticator help, it's still going to give you the help commands for Heptio Authenticator AWS. So I think it was a pretty recent name change, but it's the same thing. So that's just the authentication tool that EKS is using to access your cluster. So as I said before, we need to have AWS credentials on hand in order to access the EKS cluster. I'm going to put them in a file called EKSENV. This is just the AWS access key ID and the AWS secret access key. This is very similar to what you need to set up on your local machine in order to use the AWS CLI. You can certainly add your default region, the AWS default region environment variable in there as well. But you need to have those environment variables available to your CodeShip build in order to give access to your AWS account. The next part is a little bit tricky, so I'm going to kind of walk through it step by step. We have that kubeconfig file on our local machine that's helping us connect from our local machine using kubecontrol to our EKS cluster. We basically want to take that config and make it into a nice consumable package so that we can consume it and use it during a CodeShip build. And the best way to do that for a CodeShip build is to simply flatten and minify that kubeconfig and pass it into our build as an environment variable that's encrypted. That way the CodeShip build can unencrypt it, decrypt it, and then use it inside the build. And you're able to commit it to your repo encrypted and then decrypt it locally with the key. So there are a couple steps to do that. It is pretty straightforward and easy to script if you have to do it a bunch of times, but I recommend just first checking the current context to make sure that it's AWS, to make sure that you're using the config from your EKS cluster and maybe not a different cluster. Once you do that, you can take the output of kubectl config view, pass in minify and flatten to make it a little bit more manageable, and just save that to some arbitrary intermittent file that I happen to call kubeconfig data in this example. CodeShip has a helper script to take that data and turn it into an environment variable that we can then consume in the CodeShip build. You it's distributed as a Docker container. You can just Docker run this CodeShip environment envar helper image, pass in that kubeconfig data, and what you'll get out is that nice environment variable that CodeShip can use during the build. So I just decided to call it Kubernetes env. And then all I'll do is just append that Kubernetes environment variable with my kubeconfig to my AWS credentials. Then I just have one file that I need to encrypt, and I'm going to do that via the CodeShip jet CLI. The command is jet encrypt. I'm going to give it my plain text credentials and then give it the file name that I want. And then last but not least, the most important step is to either remove those files or add them to your git ignore if you don't want to remove them. That makes sure that you won't accidentally commit them to source control or anything. So it's definitely a couple steps. We're working on hopefully creating a slightly better user experience for it, but the good thing is it works and it's reproducible and we have that nice image. So this is one thing that you'll do kind of once when you set up the project and you shouldn't have to touch again. So now I have my credentials all set up, but I need to actually define the environment for CI/CD and then define some commands to run against my environment. And the way that CodeShip does that is by two configuration files. There's the CodeShip services file. That's a list of all the services. So for example, we have a voting service and a result service and a work service. Those will be the services that define the environment for whatever commands we want to run. So automated tests, deployment commands, etc. CodeShip services.yaml is really similar to Docker compose.yaml. So if you're familiar with using containers for development, you can more or less copy and paste everything from your Docker compose file and put it into a CodeShip services file. There's a couple extra stuff like caching that isn't available in Docker compose, but it's more or less easy enough to kind of port over. And for our deployment, I'm just going to create a service called kubectl, and I'm going to use an image from CodeShip called EKS kubectl. This particular image has kubectl from AWS. It has the AWS IAM authenticator. And then it also has that nice helper script to sort of do the inverse of what we did with our kubeconfig. So this service will make it possible to connect to your EKS cluster by reading that kubeconfig out of the environment variable that we created and encrypted in the previous step. Taking that service, we want to define some commands to run against it. And that's done in the CodeShip steps file. I want this step to be called EKS deployment, and I'm going to run it against the kubectl service that we just defined. The tag is really important because we don't want this to run on anything that's not the master branch. So I'm going to say tag master just to make sure that it doesn't run on staging, it doesn't run on a feature branch, it only runs after things have been gone through the PR process and gotten some review from peers. And then I'm going to run my deployment command, which is just a little script that I have in the deploy folder. These two things together are sort of the base interaction in order to deploy to your EKS cluster. But I have to tell you, it's not as simple as just like having code in a CodeShip build or any other CI/CD build and magically pushing new code to an EKS cluster. There's still quite a lot of other stuff that we have to worry about. And this gets back to, again, the manage, not magic. EKS is really concerned with your infrastructure. It's concerned about the compute, the volumes, the whatever else you need, VPCs to run your Kubernetes cluster. it's not a hand-holdy Kubernetes service. So when you're talking about deploying to Kubernetes, all the stuff and like, for better or worse, it's still there and you still need to solve those problems. So you still need to package your application code into container images. You still need to push those images to a registry, issue commands against your cluster in order to apply the changes, and then deal with extra requirements like storage classes, et cetera, to make sure that Kubernetes can function. The really nice thing about EKS is that just because it's AWS and really tightly coupled to the AWS infrastructure doesn't mean that you're necessarily locked in to use other tools from AWS like their registry, which is ECR. You can definitely use Docker Hub or Key.io or your own registry. And it might be just slightly easier to use ECR because there's some credential overlap, but you're certainly not locked in. So you can still kind of flexibly use whatever images you need or push to whatever registries you want to during your CI/CD. So in practice, what this looks like for our particular application, and we'll run through all of this in just a minute, is that I need to kind of do two things. I need to first push all of my images to a registry, and then I need to run my deploy script. So these two examples of the CodeShip services, CodeShip steps are talking about a push step, which is a special type of step that CodeShip offers to help you push your images to whatever registry you need to. So that's the whole point of the step. It doesn't do anything else, doesn't run tests. It simply just pushes your images. And then the extra step to deploy to my Kubernetes cluster, to my EKS cluster, that's the same one that we went over before. I want to call out one best practice for containerized applications over on the left-hand side, is that I'm tagging my image with the commit ID. And if you are using the latest tag by default, I think this is something you might want to reconsider, to pin the tag to a commit SHA or a numbered version or something else other than latest. Using latest is really, it's not suggested because it is a floating point. It's just going to grab whatever the latest image was. So if you can do something to be a little bit more precise and to pin those image tags to an event like a commit or a particular version, you'll have much better results and quite reduce your risk by quite a lot in production. So there's really no magic. You still have to deal with the image push and pull and everything else. If you're more of a visual learner, what I just described sort of looks like this in practice. So CodeShip build is going to take your source code from GitHub or whatever SDM. It's going to build and tag the images. It's going to push them to a registry because you have to have them on a registry so that your EKS cluster can pull them down. CodeShip will then issue a command to update your deployment or whatever kind of deployment strategy you have. Issue that command against the cluster, and then the cluster can then pull the images that you just pushed. What we won't talk about and what's really important is that there is a lot of other work that happens after that deployment event to your EKS cluster. There's monitoring, observing, alerting, whatever other kinds of testing you might do once something's maybe in staging or in production. EKS, again, is really just concerned with your infrastructure, so it is not going to do any of that for you. You still have to take care of it yourself, and it's still a really important part of running any application in EKS or Kubernetes or just in containers themselves. Make sure that you don't forget that, because it's never fun to wake up at 3 a.m. to something being on fire. Cool. Let's take a little bit of a test drive. So we have our tabs versus spaces, and I want to just go through that entire process and show you what it actually looks like to deploy to EKS using a tool like CodeShip. So we have our example voting app, and we can look that we are on the master branch, which is not good. We should start on a feature branch, but we have modified that result and the vote file to switch to tabs versus spaces. So I want to create a new feature branch. And I'm just going to commit and then push up. So notice like the reason that I'm emphasizing the feature branch is that we have certain actions in our CI/CD build that are restricted to particular branch names, that branch being master. So I want to go over here and actually look at what a build looks like on CodeShip. We could look at the YAML files, but they're expressed to us here in visual form. I think it's a little bit easier to understand. We have 3 testing steps and they're running in parallel. We have our vote, our result, and our worker. We can drill down into each of these steps and we see that the worker is pulling down the image, and then it will start running its kind of fake tests that are echoing past for educational purposes only. But this build will finish up pretty soon. They usually take about, there we go, test pass. That's great. Since this is a feature branch, this is the furthest it's going to go. I don't want to push this image because it's just a feature branch, and I certainly don't want to deploy it. What I can do though is, following best practices, is open up a pull request on GitHub and then use that green build as sort of like the okay or the thumbs up to merge something. So I'm going to merge from my feature branch into master. I'm going to create the PR, and because this is a lawless society and I don't want to ask for review, I'm just going to merge it. I feel okay about that though, because I have already run the build on CodeShip and I see that I have a little green check mark. So I'm going to confirm the merge. This merge event is also going to trigger a new build on CodeShip. And this is where we can see where that tagging really helps us. Because now, instead of having these push events kind of grayed out, since I'm on master, they're going to run. So this is going to take just about a minute or a little bit over a minute to run. So instead of boring you with watching the terminal output, I'll go over a couple best practices for CI/CD before we go back and look at the output and look at our changes actually in production on our EKS cluster, which is what we've been waiting for this whole time. So just to close out the webinar, a couple of tips and tricks for CI/CD. Use encryption. So I'm a big fan of config as code and having everything in a repository. Of course, there are secrets that need to go into CI/CD builds. So encryption is really, really important. Some CI/CD tools, and even on CodeShip, you're also able to configure those secrets in the UI. When you do it, though, is config as code, you will encrypt it, just like we went through with the jet encrypt and decrypt. The other really important thing about not just CI/CD, but about running containerized applications in general, is that when the container is running and you see that output from kubectl or from Docker saying like, yeah, the container's up, way to go, doesn't actually mean that the service is available. And you might get some crash loops because, for example, databases are not, they don't start up super quick. So there are things called health checks. That's kind of the general term, but it's basically saying like, hey, we know that the database is up when we can select something from a table. That will kind of block the process to say, don't try to query the database until the health check passed. So that can help you avoid failing tests just because the service isn't available. It can help alert you if you've maybe your CI/CD tests have passed. And you didn't see something, and then when you actually deploy something to production, the health check doesn't pass. That's a really good way to alert it. Manual approval is also a really interesting and helpful thing. So I am demoing this full-fledged CI/CD workflow where I'm just going to commit to master, and then whatever is on master is going to be deployed. That might not be something that your company is ready for. So CodeShip does also have manual approval. And I can show you what that looks like in just a little bit after this deployment finishes, but it basically gives a certain subset of users the capability of approving a build before it gets deployed. And speaking of deployments, we can go back here and take a look at what our little output is. So we've pushed all of our images to the Docker Hub, and it's going to use the image tag of the commit which starts with 1FD. So I can see that this tag with 1FD was pushed, and it's the same for all of my images. And then I have my output of my EKS deployment. So I'm just running a kubectl apply with the deployment, the services, and the persistent volume claim. So we can see some of these things weren't changed, like the persistent volume claim was not changed, but the app vote was configured. So we should be able to go back here and take a look and see that it's actually tabs versus spaces now. So we've gone through the whole process, and if we refresh this as well, we can see that this has been thankfully changed to tabs versus spaces as well. So we did it. It was a little bit complex and had quite a few steps, but the configuration is something that you only need to do pretty much one time at the beginning of your project, maybe do a couple fine tunes throughout the process. And then you are good to go. I can double check and verify to make sure that my my images have pushed up here, and I can see that it was just last pushed 3 minutes ago. The final thing I want to show before taking some of your questions is the manual approval step. So I've taken liberty of preparing the PR beforehand just to make sure that we have it and we have enough time. So this is introducing to you a new step type called manual. I'm going to make sure this manual step is only applicable for builds running on master, and then I'm just going to hide my EKS deployment behind it. So when I merge this, I'm going to sort of enable now manual steps, and we'll be able to see what a manual step, or sort of like the pause build, looks like. I am an owner of my project, and that gives me the ability to approve it. There we go. Cool. So we see this new step type, and it'll just take a couple seconds for us to get that far. In the meantime, I'll answer 1 or 2 questions.
Okay. We've gotten a lot of questions in, so why don't we go ahead and dive in, and then we can finish that up. The first question is, how do we import existing Kubernetes or Docker containers on premises to EKS?
That is a good question. So the way that you distribute code to run on EKS is through the image. So if you're asking about, like, I have a Kubernetes cluster that's running on premise and I want that exact thing running on EKS, you will have some artifact like that deployment file that you should be able to tear down and start up. I think the other thing to worry about is, like, what are the security permissions, and, like, how do you have your images locked down? So you can use private registries, and you just need to make sure to pass the credentials into your private registry. So if you have a registry on premise, like, you have to just make sure that your cluster has the credentials in order to pull from that particular private registry.
All right, great. Do you need to get back to your presentation there, or can I do another question?
I will just press that button, and that's really it. That little modal came up, and I see that there's a little bit of a pause state. As an owner, I can approve it, and that just basically stopped time in my build, so that maybe you want QA to double check something, or there's a deploy to staging before you want to deploy to production. That gives you just a little bit of extra control over your deployment process.
More questions, or are we good?
Yeah, let's talk about, there's one question that I'm very interested in answering, which is, how is CodeShip different from Jenkins X? And that's a very interesting question. So Jenkins X is a new open source project that's spearheaded by a couple of extremely talented and enthusiastic engineers who also work at CloudBees, who previously came from Red Hat and have a ton of experience. So Jenkins X is sort of like the next generation of Jenkins as you know it. It's meant to be cloud native and focus on a GitOps workflow. and get you started really quickly. So it's not just like being able to run builds with Jenkins, it's really giving you the possibility to deploy to multiple environments using Jenkins X, also set up your pipeline for you in a much easier way. And it's designed for Kubernetes applications specifically, and we're kind of placing a big bet on Kubernetes, and then the process of GitOps being a best practice going forward. CodeShip is a little bit more agnostic, and CodeShip is pretty much equivalent to a lot of the Jenkins functionality. So it's a test runner. You have your pipeline. You can define what you want to run in your pipeline, deploy to whatever deployment target you want. CodeShip is a little bit less opinionated, though. You don't have to be using Kubernetes. We don't use Jenkins to make CodeShip work. It's its own build runner, so that's a big difference. And then CodeShip is also hosted as a SaaS, whereas Jenkins X is not. Jenkins X is something that you need to manage yourself. CodeShip is a subscription, so you'll have an account on CodeShip and then interact with it that way.
Okay. Looks like we're about 5 minutes top of the hour, so I think we have time for one more question. How about this one? How does CodeShip manage different AWS accounts on the same VM slave?
Yeah, so that's actually a pattern that we don't see very often. Because CI/CD in general, like you have a pretty nice, tidy separation of concerns. So if I have my my example voting app project, I'm going to have just one user that has the credentials necessary to deploy to whatever I need. So I think the important thing, and maybe I'm reading a bit into this question, is that the build machines are ephemeral. So we have it for your build and then we tear it down. So there's never a need to sort of like switch for different accounts because you're going to be using the same build machine for different projects. It's only ever going to be one project. But if you do need to switch between accounts, like AWS CLI allows you to do that, and we have the AWS CLI images available to you. So you can pass in that configuration file and kind of switch between the accounts like you would just normally. I have to say it's probably not the workflow that a tool like CodeShip is optimized for, though.
Okay, all right, great. So we're going to do one more question. In CI/CD, can I integrate custom in-house tools like SonarQube?
So you can use CodeShip's API, and I think that's probably the best way to integrate with other in-house tools. So for example, if you want one thing that's running on an in-house tool to then kick off a job on CodeShip, or when CodeShip finishes, maybe you want it to reach out to whatever, give CodeShip build machine access to something else. Those kind of chained event workflows are possible with the CodeShip API. So there's certainly a way to do it. Most people that use CodeShip kind of have CodeShip responsible for maybe just the CI portion, but many people the CI and the CD portion. So running the tests and then also deploying. But yeah, you can customize it to kind of do what you need to do with whatever tool set.
Okay, all right, great. Well, that is about all the time, unfortunately, that we have for the questions. But I do want to let the audience know that if you did not get your question answered, Laura will be getting all of these questions, and either she or somebody from her organization, I'm sure, will be more than happy to follow up with you post-event to get your question answered. I also want to remind the audience that today's event has been recorded, so if you missed any or all of it, you will be able to access it on demand. We're going to be sending out an email link post-event that will take you to the event directly. It's also going to be living on the DevOps.com DevOps.com website under the webinars tab. You can just go there directly and access it. While you're there, go ahead and check out all the other webinars that we have, both upcoming and on demand. Hopefully there'll be one or two that pique your interest. Laura, thank you so much for giving such a great presentation. I know I got a lot out of it. Also want to remind the audience that they're going to be at DevOps World, Jenkins World, DevOps World, of course. So I will be there as well, actually giving a presentation on Wednesday. So hopefully folks will be there and they can say hi to Laura and they can say hi to me too. So if you need information about DevOps World, it's www.cloudbees.com. com/devops-world. Go ahead and check that out. And then Laura has given you a 20% off coupon there with the code here, JWL Taco. So Laura, again, thank you so much for giving such a great presentation. And I will see you at DevOps World, Jenkins World.
Great, thank you so much. And I already have the slides up. They're on this bit.ly EKS CodeShip link, so feel free to check out the slides there.
Awesome, awesome. All right, well, thank you everybody for joining us today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.